NASA's Mars rover unveils a chilling discovery on Mars that will transform our understanding of the universe. Since the first human-made objects were sent into space, Mars has held a unique place in our collective imagination. The red planet, with its barren landscapes, towering volcanoes, and vast canyons, has long been the subject of speculation about alien life and ancient civilizations. NASA's Mars rover missions, from Curiosity to Perseverance, have transformed our understanding of Mars from an arid, lifeless wasteland to a world with a complex and fascinating history. Now, a recent discovery by NASA's Perseverance rover has sent shockwaves through the scientific community, providing evidence that could fundamentally reshape our understanding of Mars and our place in the cosmos. This chilling revelation suggests that Mars may have been much more similar to Earth than we ever thought possible, and it raises profound questions about life beyond our planet. Mars, a brief history of exploration and discovery. Human curiosity about Mars goes back centuries. Since early telescopic observations, Mars has been a world that beckoned with mystery. With its polar ice caps, seasonal changes, and surface markings, early astronomers wondered if Mars could support life. While we now know Mars lacks the dense atmosphere and liquid water necessary to sustain complex organisms, robotic missions over the past few decades have provided tantalizing evidence that water once flowed across the Martian surface and that life, at least microbial life, might have had the conditions it needed to flourish. In 2021, NASA's Perseverance rover landed in Jezero Crater, a region believed to be the site of an ancient lakebed. Perseverance's mission is to search for signs of ancient life, gather rock and soil samples, and lay the groundwork for future human exploration. While past rovers like Spirit, Opportunity, and Curiosity made incredible strides in characterizing Mars's geology and climate, Perseverance has taken things a step further. Its findings are the most direct evidence yet that Mars may have harbored life. The chilling discovery, traces of organic compounds in Jezero Crater. The most shocking discovery came as Perseverance explored the sedimentary rocks in Jezero Crater. Using its advanced suite of instruments, the rover detected organic molecules preserved within the Martian rock formations. Organic molecules, which consist of carbon and hydrogen, are the basic building blocks of life as we know it. While their presence alone doesn't prove that life existed on Mars, it does suggest that the environment was once favorable for biological processes. Sherlock, Perseverance's specialized instrument for scanning habitable environments, was able to pinpoint these organic compounds with remarkable precision. The presence of organic molecules, combined with the sedimentary layering of the rocks in Jezero Crater, suggests that these molecules were preserved in ancient lake deposits. This finding could indicate that Mars once had a stable climate, water flow, and potentially even a habitable environment where life could emerge. The discovery of organic molecules is chilling because it forces us to confront the possibility that life once existed on Mars. This raises a host of questions about Mars's past and our understanding of where life can arise in the universe. Evidence of ancient water and hydrothermal activity on Mars. While organic molecules are a crucial component for life, they're only part of the story. Water, a key ingredient for life, has also been observed across Mars in the form of ancient river valleys, dried lake beds, and polar ice caps. But Perseverance's latest discovery takes things a step further. The rover found minerals within Martian rocks that indicate the presence of hydrothermal activity, heated water interacting with rocks beneath the surface. On Earth, hydrothermal systems create ideal conditions for life. These environments, found around volcanic vents on the ocean floor, are rich in minerals and provide warmth, allowing ecosystems to thrive even in complete darkness. The discovery of similar mineral structures on Mars is significant. It suggests that not only did Mars have surface water, but it may have also had underground hydrothermal systems, environments that could support microbial life. The possibility of hydrothermal activity on Mars suggests that life could have survived even as the planet's surface became inhospitable. This finding hints at the potential for life to exist in other extreme environments throughout the universe, from icy moons like Europa and Enceladus to planets orbiting distant stars. The implications of finding organic molecules. Perseverance's detection of organic molecules in Martian rocks has profound implications for the field of astrobiology. Organic compounds are a prerequisite for life, and their presence on Mars aligns with the notion that life can arise anywhere conditions are favorable. In the context of our solar system, this discovery raises questions about the likelihood of life on other planetary bodies. Could life exist on Venus, within the acidic clouds of its atmosphere? Or on Europa, Jupiter's moon with its subsurface ocean? Furthermore, the discovery of organic molecules on Mars adds weight to the hypothesis that life on Earth might have originated elsewhere and traveled here via meteorites, a concept known as panspermia. Mars and Earth have exchanged material for billions of years through asteroid impacts, making it possible that life could have migrated from one planet to another. If organic compounds, or even microbial life, are eventually found on Mars, it could suggest that life in our solar system is more interconnected than we ever imagined. Mars's changing climate, a world in flux. Mars's climate today is cold and dry, with temperatures that often plunge below -80 degrees Fahrenheit. However, evidence gathered from previous missions and reinforced by Perseverance suggests that Mars was once much warmer and wetter. Geological formations, river valleys, and sedimentary rocks indicate that Mars had lakes, rivers, and perhaps even a shallow ocean. The climate shift on Mars is thought to have occurred billions of years ago as the planet lost its atmosphere. Without a strong magnetic field to protect it from the solar wind, Mars gradually lost its atmospheric gases to space, resulting in a drastic change in climate. This change would have transformed Mars from a potentially habitable world into the frigid desert we see today. What makes Perseverance's findings even more remarkable is that the organic compounds were preserved despite Mars's harsh climate. The presence of these compounds within ancient rocks indicates that Mars's lake and river systems could have supported life before the planet's climate changed. It also suggests that if life did emerge on Mars, it might have adapted to survive in hidden pockets beneath the surface, shielded from radiation and extreme temperatures. Searching for ancient life. The Mars Sample Return Mission. Perseverance's mission has always been more than a search for Martian rocks. It is part of a larger, multi-decade effort to answer the age-old question. Are we alone in the universe? NASA and the European Space Agency, ESA, have plans to retrieve the samples Perseverance is collecting in Jezero crater and bring them back to Earth through the Mars Sample Return Mission. These samples, preserved in airtight containers, will undergo rigorous analysis in Earth-based laboratories. By studying the organic molecules and mineral structures in these samples, scientists hope to determine whether they were formed through biological or geological processes. This kind of analysis is essential to understanding the origins of the organic compounds on Mars and could provide definitive evidence of past life. The Mars Sample Return Mission is also significant for preparing for human exploration of Mars. Understanding the potential risks and resources available on Mars will be essential for future crewed missions to the Red Planet. A new perspective on life in the universe. The discovery of organic molecules and the possibility of ancient hydrothermal activity on Mars compel us to reconsider the conditions necessary for life. For years, Earth's Goldilocks zone, the narrow band around the Sun where conditions are just right for liquid water, was seen as unique. However, the findings from Mars suggest that life could emerge in environments far different from Earth's. The discovery also challenges our assumptions about what it means to be habitable. While Earth-like planets with liquid water on the surface might be rare, environments like those on Mars, with intermittent water and geothermal activity, may be more common than we thought. If life can survive in these environments, it suggests that the universe might be teeming with microbial life in places we once overlooked. The philosophical implications of Martian life. The discovery of organic molecules on Mars isn't just a scientific breakthrough, it's a philosophical one. If life did exist on Mars, it would imply that life is not unique to Earth, but rather a common phenomenon in the universe. This revelation would fundamentally alter our understanding of humanity's place in the cosmos and challenge long-standing philosophical and religious views. Moreover, the discovery would spark questions about the nature of life itself. Is life defined by a specific set of biological processes, or is it something more fundamental? If life can exist in extreme environments on Mars, what does this mean for our definitions of life, intelligence, and consciousness? The discovery could also have ethical implications. If microbial life exists on Mars today, it would raise questions about the impact of human exploration on the Martian ecosystem. Preserving potential Martian life would be crucial as we consider sending humans to Mars. Preparing for the next phase of exploration. Perseverance's findings represent just the beginning of a new era of exploration on Mars. The Mars Sample Return mission, planned for the early 2030s, will allow scientists to analyze Martian rock and soil samples in unparalleled detail. Additionally, future missions could explore Mars's subsurface, where liquid water might still exist, shielded from harsh surface conditions. NASA and other space agencies are developing technology that could drill deep into the Martian crust, allowing scientists to search for life in protected habitats. If we find evidence of current microbial life, it would suggest that life can survive under the harshest conditions and reinforce the idea that life could exist on icy moons like Europa and Enceladus, or even on exoplanets orbiting distant stars. Conclusion: a universe teeming with possibilities. NASA's Perseverance rover has provided a chilling glimpse into Mars's ancient past, revealing that the red planet might have been far more Earth-like and far more hospitable to life than we previously imagined. The discovery of organic molecules and evidence of past hydrothermal activity suggests that Mars once had the ingredients needed to support life. This discovery not only changes our view of Mars, but also expands our understanding of the conditions under which life can exist. As we prepare for the next steps in Mars exploration, humanity is closer than ever to answering the profound question of whether we are alone in the universe. With each new discovery, we are reminded that Mars is more than a desolate rock orbiting the Sun. It is a world with a history, a story, and perhaps even signs of life. In exploring Mars, we are not just seeking answers about the red planet. We are seeking answers about ourselves, our origins, and our place in the vast cosmos. The universe, it seems, may be far more alive than we ever dared to imagine.